PCA stress block. Ano yung PCA na sinasabi? Ha? Miss Samantha. Si Samantha, tanungin natin siya. Ano yung ibig sabihin ng PCA, Samantha?
Portland Cement Association po, sir.
Okay, so Portland Cement Association, when can you please open your camera pag nagsalita kayo para ma-acknowledge ko lang kayo mabuti, no? Okay, if that's not hindi naman hassle, if you can open it, no? Okay, so Portland Cement Association is a partner of ACI when it comes to dealing with a lot of researches on concrete reinforced concrete design and analysis, especially yung sa code, no? Sa code preparation uh, and final drafting ng mga provisions. Okay? So, pag sinabing PCA, ACI, halos isa na lang yan. Okay? So, this PCA is actually our basis for many formula concerning the parameters involved in the use of yung ating mga parameters na ginagamit in terms of the design and analysis of not only flexural members but also other types of members, may it be axial, uniaxial, combination of torsion and bending. Okay, so yung mga ginagamit nating mga parameters, the PCA contributes a lot to it. Okay, so this is now the figure on what is the PCA stress block is giving us in terms of the stress strain property of your concrete. Okay, so we have here, this graph is almost not linear but almost linear at this point, up to about 0.5 or 0.6 maybe, and then the abrupt change in curvature at around 0.8. Okay, and then at its peak, it is assumed to continue its strain increase without change in the stress. Okay, so this is actually horizontal. Okay, horizontal siya, no? While the Hagnestad, dito sila nagkaiba, no? Pababa siya, no? So ito yung PCA, ito yung Hagnestad model. Okay, so merong konting drop. Okay, we cannot say that the PCA is much more accurate, Hagnestad is much more conservative, blah blah, without really looking into the history of the results obtained from a series of tests where the graph was finally patterned, no? So hindi natin masasabi 'yon unless we are the ones na gumawa dito, eh. Okay? Now, what I'd like to present to you in this particular part of the lecture is on how to deal with the moment capacity using the stress block parameters K1, K2, and K3 using the PCA stress block distribution. Okay, so the PCA stress block distribution defines the curve by separating this graph and this graph here at a point epsilon O, okay, for which your FC at this point, which is I think almost at the elastic range. So we have here the elastic part, and this is the inelastic part, is defined by these two equations. Okay, so when epsilon c, okay, is in between, let's say epsilon c is in between 0 and epsilon o, then uh, your value of fc is defined by equation 1. Okay, but if your epsilon c is no longer between that and it exceeds epsilon o but less than epsilon u or cu, it will actually fall only at one point there, which is horizontal, which 0.85 fc prime. Okay, so this is just what the ACI is all about. Okay, simple. Now, the definition for epsilon O on the elastic stage is based on this formula, wherein your stress-strain relation is defined in terms of 2 times 0.85 fc prime over EC, where EC is the secant modulus of elasticity. Okay, so that's 4700 square root of fc prime. Now for case 1 and case 2, the equation that was derived based on the procedure I presented above is this one. Okay, using the same procedure I used a while ago, your LO will be simply the integral of this one here. So this is sigma, function of epsilon c. Take note that your Greek letter kasi is simply the x that I'm dealing with. So this is just a Greek letter, and this is just the alphabet. Okay? Yung x kasi, yung x, ang Greek equivalent niya is this letter x ito sa Greek. No? So this is pronounced as kasi. Okay? I did not change it to x because I want you to be accustomed to using this Greek letter again to show that you are at the different level than the undergraduate class. Okay, so we will be using a lot of Greek letters rather than alphabetic letters. Okay, yung alphabets, iwasan natin. No? So, mas maganda, gamitan natin sila ng Greek letters. Okay? Now, for LO, if I will integrate this, I will arrive with this. Okay, you ought to verify. You try to integrate it, this one here. Okay, what function are you going to use here? You use the function on case 1. Okay, what's the function? Okay, so case 1, ito yan. FC is 0.85 FC prime. So, i-substitute mo siya dito. dito, and then makukuha mo ito. Okay? Of course, lambda will not appear just like that because lambda is defined at the bottom here. Kailangan substitute mo pa ito, no? Okay? So, lambda is in terms of cases of O, lambdas of O, and lambdas of U is in terms of epsilon CU, ultimate. Just like this is the lambda O is the reciprocal of the transformation variable cases of O, and this is the reciprocal of the transformation variable at the ultimate stage, which is epsilon CU. Okay, so something like that. So you have to verify this by integration. And you also can get K2. Again, what is K2? This is 1 minus L 1 over LO. Okay. Okay, you can verify again by integration. So, may answer na siya, di ba? Okay, so in case 2, ganun din. This is verified. This must be verified. Okay, so lambda O is 1 over cases of O rather. And where cases of O is simply epsilon O over epsilon C, or simply your YO over KD. So what is your YO? YO is the distance from the neutral axis to the fiber at the point wherein the stress is starting to have a value of 0.85 FC prime. Kasi dito mababa pa siya. So nandito siya, sakto dito, no? Okay, so you have to verify or get what YO is using again this formula. Because you know epsilon O, given FC prime and EC, you can easily get your epsilon O here. Okay? So using this formula here. So parang nag-iterate ka. If you start iterating from 0.00000, what is epsilon 0? 003, okay? What is epsilon O? Will you compute it if FC prime is 20 and EC is 4700, the square root of 20, okay? So you can get epsilon O. You have a value here. So you can iterate from here and then you get this value. So at exactly epsilon O here, exactly epsilon O, what is your cases of O if this is equal to that? Okay? So what will be your YO? YO is simply KD value. Okay? So KD value there. So you just get you now get your values on the basis of assuming your iteration starts from 0 up to epsilon C, which is the final. So this is how to deal with it using iteration. Okay, so let's move to moment capacity. For a rectangular section, what happens with your formula? We know that our formula for rectangular section is simply equilibrium, or sorry, your neutral axis is simply defined on the basis of equilibrium condition. So this is CC. What is this? This is LO. LOFC prime BOKD is equal to ASFY. So you can get KD. Okay, so this is your KD. And if I get your moment is CCZ or TZ, I now get Z equals D minus K2 KD. I will now get D minus K2, I insert KD there. So I, what? I factor out D. So my value for Z now becomes D, 1 minus this value here. Okay, so paano ka nakapag-factor ng D dito? Eh wala ka naman D doon. Ha? So how can you do that? Can you factor out something that is not present in the expression? Anybody?
I think, sir, ay, yes, sir. Yung AS is equal to rho BT.
You just answer my question. Can you factor something which is not present in the expression? Yes or no?
No po.
Huh? Okay,
No
so the
po,
answer,
sir.
yes. Anybody? Any other answer? Rexter, no?
Wait, sir. Possible pala, sir. Pero magkakaroon po ng denominator na D.
Okay. So it's possible by multiplying it with D, okay? And over D.
Yes, sir.
And
Over
AS
D.
over
Yes.
BD is raw, okay? And then you just proceed, okay? Okay, so I will no longer elaborate on that. It's just para hindi lang kayo mainip. Kaya ako tinanong yan, okay? Okay, so Mn now is K1, etc. blah blah blah. So these two equations here on top, equations 15.1 and 15.2 here, sana yun? Wala. One point 5.1 and 1.5.2. Okay, so these equations here are the equations which are identical, no? They are just the same. Kaya lang, ang kamukha nito is yung concrete. Okay, concrete part to yung steel. Okay, so this is your Mn is equal to ZCC Z and Mn equals Tz. Okay, so if we know K1, K2, K3, then Mn can readily be solved. Note that ACI code allows us to use any distribution of the compressive stress as long as the computed magnitude and location is in close agreement with the material stress and strain properties. Remember this one, class, no? Close agreement with the material stress and strain property obtained from the laboratory. Okay, so when you have a material, let's say a cylinder, which it has a different property. Okay, you can come up with test analysis or laboratory test experiments that will yield your K1, K2, and K3. Okay? Ang mapapalitan nun, yung stress block parameters mo. So you're no longer using the stress block parameter of Whitney and so on. Okay? So if you're using a PCA model, you are using this model here. So you're just like using the test result of PCA. If you're using Hagnestad, You're just like using the test data of Hagnestad. Okay? So if you have a different material property, you can no longer use this because this has some limitations on, okay, on the basis of what the property was used. In fact, may mga uh, test tayo na pag hinaluan mo na ng ibang material, nagkakaroon ng ibang result yung formula mo. No? Maybe your beta 1 cannot reach a value of 0.85 or can actually be lower than 0.65. So something like that. Okay, so be careful, no, when you're using equations. So you must go and refer to whatever history it was taken from. So dahil tayo ginagamit naman natin equation ni Whitney, parameter tayo, so yun yung susundin natin. Normal aggregate concrete, light aggregate concrete. So meron tayong limitation doon sa aggregate size, meron tayong limitation sa mixture, okay? Meron tayong limitation sa type of cement, meron tayong limitation sa water cement ratio. So all the properties involved in mixing a normal aggregate concrete or a lightweight aggregate concrete must be followed, or else wala, hindi ka, parang ano lang yan yung COVID, ano na yung gamot na inaano nila ngayon sa COVID, ivermectin ba yon? So okay, so kung hindi mo naman nabasa yung history ng pagkakagawa ng gamot at sinabi na ng doktor na hindi kulang pa yung test, nasa sayo na kung susubukan mo, no? Diba? So scientific basis must be always present whenever you are trying to analyze something on the basis of science. Okay? Close agreement. Close agreement. That's the key word there. So let's go back to Whitney's block. From the laboratory test, the following stress block relations were obtained. Okay, so Whitney's experiment, to summarize it all, simply concluded that K1, K3, or simply LO, this is LO, is 0.85 beta 1. And K2 is simply 1/2 of beta 1. Okay? Where beta 1 is, this is the model, okay, based on the model he used in experiment. He found out that beta 1 is within this range when FC prime is less than or equal to 28, and it cannot be less than 0.65. So it must always be greater or equal to 0.65. And beta 1 is parang baligtad dito. Okay. So sorry class, no? So this formula is for FC prime greater than 28 megapascal, and for beta 1 less than or equal to 28 megapascal, it is 0.85. So I'm sorry for the error. Okay, the equations 1.5.1 and 1.5.2 can now be simplified on the basis of Whitney's parameter. So pag ginamit na natin yung Whitney dun sa ating dinerive na formula, okay, ito na yon. Okay, so this is 0.85 FC prime, BO, beta 1 KD, simply your A, di ba? So ito yung 0.85 F prime C AB. Okay? Parang ganyan lang siya, di ba? A, where A is equal to beta 1C. Your C is actually your KD, no? Okay, your KD. I'm not using the letter C because C sometimes is conflicted with the variable compressive force. Okay, and this is for your steel. This is for concrete, and this is for steel. So for the steel part, this is your CCZ and this is your TZ. Okay, so rho FYBOD squared 1 minus 0.5 rho M, where A is equal to ASFY 0.85 FC prime BO and M is Fy over 0.85 FC prime. Note that KD is the distance from the extreme compression fiber to the neutral axis NA. Okay, so that ends your flexural concept. It's as easy as understanding 10 slides or 10 pages na pinag-aralan natin, halos ilang chapter yan sa libro. Ito lang ibig niya sabihin. So if you're talking of double reinforced beam, T-beam, L-beam, hollow beam, triangular beam, lahat ng beams kasama na dyan. Ganyan-ganyan din ang analysis niya. Okay, so that is my first lecture on flexural members. So if you have questions, we can